Dear student, today I will discuss a new chapter, that is your solution. This is your new chapter, and first I will explain about the meaning of solution. Solution is a homogeneous mixture whose composition vary up to a limited stage. So I can write a solution is a homogeneous mixture of two or more substances whose composition can be varied within certain limit. The substance which are used for the formation of solution is called component. Next I will explain about the characteristics of solution. The components of the solution cannot be separated by filtration or cannot be separated by subjecting the solution for settle down under the effect of gravity. The components of the solution can be separated by evaporation, distillation, crystallization, like this. By this process, the constituent particle can be separated. Remember another characteristics point: every constituent particle show their individual property in the solution to prove their presence in the solution. These are the characteristics of the solution. Next, I will explain about the classification of solution. Depending upon the number of components by which the solution is made, the solution is classified into different types. Number one is your binary solution. Number two is your tertiary solution. Number three is your quaternary solution. If a solution is made by two components, then the solution is called binary solution. If a solution is made by three components, then the solution is called tertiary solution. Like that, if a solution is made by four components, then the solution is called quaternary solution. In this chapter, generally I discuss about the binary solution. In binary solution, one component is your solute, another component is your solvent. The major component in the solution is called solvent. The minor component in the solution is called solute. Now I will explain about the types of solution. Generally we think about the types of binary solution. There are different types of binary solution depending upon the physical state of the solute and solvent. First is your solid solution. In this case, solute and solvent are present in solid state. Generally, we think about the example like the example of alloy, copper in gold, zinc in gold. These are the example of solid solution. Second is your liquid solid solution. In this case, the solute is your liquid, the solvent is your solid. Example is your mercury in sodium. Next is your gas solid solution. In this case, the solute is your in palladium. Fourth number is your solid liquid solution. In this case, the solute is your solid, the solvent is present in liquid state. Example is your sucrose in water, or you can think about NaCl in water. Next is your liquid solution. In this case, both solute and solvent is present in liquid state. Example is your alcohol in water. Next is your gas liquid solution. In this case, solute is your gas, solvent is your liquid. Example is your O2 dissolved in water. Second example is your CO2 dissolved in water. Next is your solid gas solution. In this case, solute is present in solid state, solvent is present in gaseous state. Example is your dust particles present in air. Next is your liquid gas solution. In this case, solute is your liquid, solvent is your gas. Example is your water vapor in air. Next is your gas solution. In this case, both solute and solvent present in gaseous state. Example is your mixture of different gases in air. These are different types of solution. There are also other type of solution. First is your aqueous solution. In aqueous solution, the solvent is your water. So I can say the solution in which the solvent is your water, then that type of solution is called aqueous solution. Next is your non-aqueous solution. The solution in which the solvent is not water, that type of solution are generally considered as a non-aqueous solution. So I can say the solution in which the water is not the solvent is called non-aqueous solution. There are large number of non-aqueous medium that is taken as solvent. The non-aqueous solvent are benzene, ether, carbon, tetrachloride, etc. These are the solvents which are used as a non-aqueous solvent in non-aqueous solution. Next type is your dilute solution. When the amount of the solute is very small as compared to the amount of the solvent, then that type of solution is called dilute solution. Next I will discuss about the saturated solution. The solution in which more amount of solute cannot dissolve, then that type of solution is called saturated solution. Next is your unsaturated unsaturated solution. The solution in which more amount of solute can dissolve, then that type of solution is called unsaturated solution. Next is your supersaturated solution. Supersaturated solution. The solution which contain more amount of solute than the needed for the preparation of the saturated solution, then that type of solution is called supersaturated solution. Next I will explain about the standard solution. The solution whose strength is known, then that type of solution are called standard solution. These are the other types of solution which is also necessary for us. Next I will discuss about the solubility. Suppose I want to prepare a solution. For the solution, suppose I will take 1 liter of water. Suppose I will take 250 gram of sugar. This is the maximum amount of sugar which is dissolved in 1 liter of water at a particular temperature. Then this is said to be your solubility. That means I can write the solubility of a substance express the maximum amount of it which dissolved in a specific amount of solvent at a given temperature. This is your specific amount of solvent. Here the amount of sugar is 250. This is the maximum amount, so it is the solubility. Suppose I will take NaCl. Suppose 350 gram of NaCl is dissolved in 1 liter of water. Then this is the solubility of NaCl. This is the solubility of sugar. The basic principle of solubility is like dissolve, like formula. There are two types of solute are present. One is your polar solute, another is your non-polar solute. Similarly, two types of solvent. One is your polar solvent, another is your non-polar solvent. Remember, the polar solute always dissolve in the polar solvent. Similarly, the non-polar solute always dissolve in the non-polar solvent. Suppose I will take NaCl. NaCl is a polar solute which is always dissolve in the polar solvent like water. Suppose I will take wax. Wax is a non-polar solute which is always dissolve in the non-polar solvent like benzene, ether, like this. The solubility depends upon the following factor. Number one is nature of solute and solvent. Second is temperature. Third is pressure. Mathematically, solubility is equal to weight of solute in gram divided by weight of solvent in gram into 100. This is the formula for the calculation of solubility. Now I will solve a problem related to the solubility. 28 gram of saturated solution of a substance contains 3 gram of the solute at 300 Kelvin. Calculate the solubility of the solute at the temperature. Here weight of solute equal to 3 gram. Weight of solution is given, that is your 20 gram. We know that solubility equal to weight of solute in gram divided by weight of solvent in gram into 100. Here weight of solute is your 3 gram. but weight of solvent is not given. Here weight of solution is given. We know that weight of solution equal to weight of solute plus weight of solvent. So we can write weight of solute plus weight of solvent is equal to 20 gram. We know that weight of solute is 3 gram. So we can write 3 gram plus weight of solvent equal to 20 gram. Therefore, weight of solvent equal to 20 minus 3, that is 25 gram. Now put the weight of solvent here. So I can write solubility equal to 3 gram divided by 25 gram into 100. By solving, we can find 12. So we can write solubility of the solute at 300 Kelvin equal to 12. Next I will explain about the concentration of solution. Concentration of solution means the amount of solute present in given amount of solvent or solution. Concentration of solution means what amount of solute present in a given amount of solution or solvent. Concentration of solution is also called strength. There are different ways to express the concentration of the solution. At first I will discuss about the percentage. Percentage means number of parts by mass or volume of solute present in 100 parts by mass or volume of solution. How many parts of a solute present in 100 parts of the solution? The part must be done by the help of mass or volume. There are 4 types of percentage. Number 1 is your mass percentage. Number 2 is your mass volume percentage. Number 3 is your volume mass percentage. Number 4 is your volume percentage. At first I will discuss about the mass percentage. It is simply called M by M percentage. Mass percentage means number of gram of solute present in 100 gram of solution. Mass percentage means number of gram of solute present in 100 gram of solution. Mathematically M by M percentage is equal to weight of solute in gram divided by weight of solution in gram into 100. This is the formula for the calculation of M by M percentage. Next is your volume mass percentage. It is simply called V by M percentage. Volume mass percentage means number of ml of solute present in 100 gram of solution. Volume mass percentage means number of ml of solute present in 100 gram of solution. Mathematically, I can write V by M percentage equal to volume of solute in ml divided by mass of solution in gram into 100. Next is your mass volume percentage. This is simply called m by v percentage. Mass volume percentage means number of gram of solute present in 100 ml of solution. Mathematically I can write m by v percentage equal to mass of solute in gram divided by volume of solution in ml into 100. Next percentage is your volume percentage. This is simply called V by V percentage. Volume percentage means number of ml of solute present in 100 ml of solution. Mathematically I can write V by V percentage equal to volume of solute in ml divided by volume of solution in ml into 100. This is all about the different type of percentage. Next is your strength. It is simply symbolized as, it is also considered as gram per liter, which is also symbolized as GPL. Strength means number of gram of solute present in 1 liter of solution. How many number of solute present in 1 liter of solution? That is called strength of the solution. Mathematically I can write GPL equal to weight of solute in gram divided by volume of solution in liter. The unit of GPL is gram per liter. Next I will explain about the normality. That is symbolized as capital N. Normality means number of gram equivalent of solute present in 1 liter of solution. That means how many number of gram equivalent of solute present in 1 liter of solution. That is called normality of the solution. Mathematically I can write normality capital N equal to number of gram equivalent of solute divided by volume of solution in liter. We know that number of gram equivalent of solute means weight of the solute divided by equivalent mass. So for this term I can write weight of solute divided by equivalent mass. EM means equivalent mass. For this term I can write weight of solute divided by equivalent mass of solute. Again I can divide volume of solution in liter. Suppose this is taken V, this is taken W, then I can write W by EM into 1 by V in liter. We know that 1 liter equal to 1000 ml, 1 by V liter equal to 1000 by V ml. Instead of this term, I can use this term. So I can write normality equal to W by EM into 1000 by V in ml. The unit of normality is gram equivalent into liter inverse. Remember some important term. If a solution having normality 1n, then the solution is called normal solution. If the solution having normality 2n, then that type of solution is called binormal solution. If a solution having normality 1 by 2n, then the solution is called semi-normal solution. If the solution having normality n by 10, then the solution is called deci-normal solution. If the solution having normality n by 100, then the solution is called centi-normal solution. If the solution having normality n by 1000, then the solution is called milli-normal solution. These are the important terms. Suppose in a problem decinormal solution is given, that means we think that the normality of the solution is n by 10. Like this, you can also think about the other term. Next I will explain about the molarity. It is symbolized as capital M. Molarity means number of gram mole of solute present in 1 liter of solution. That means how many number of gram mole of solute present in 1 liter of the solution. That is called molarity of the solution. Mathematically, I can write molarity capital M equal to number of gram mole of solute divided by volume of solution in liter. We know that number of gram mole of solute equal to weight of solute divided by molecular mass. So instead of this term, I can write weight of solute in gram divided by molecular mass. Mm means molecular mass. Suppose it is taken W. Next I can divide this by volume of solution in liter. Suppose this is taken as V. Now I can write W by mm means molecular mass into 1 by V in liter. We know that 1 liter is equal to 1000 ml. So 1 by V liter equal to 1000 by V in ml. Now put this term instead of this term. So I can write molarity capital M equal to W by mm into 1000 by V in liter. The unity of molarity is gram mole into liter inverse. Next I will discuss about the molality having symbol small m. Molality means number of gram mole of solute present in 1 kilogram of solvent. How many number of gram mole of solute present in 1 kilogram of solvent? That is called molality. Mathematically, I can write molality small m equal to number of gram mole of solute divided by weight of solvent in kg. We know that number of gram mole of solute equal to weight of solute divided by molecular mass. So I can write weight of solute in gram divided by molecular mass of solute Suppose this is taken as small w and suppose this is taken as capital W. So I can write molality equal to small w by molecular mass into 1 by capital W in kg. We know that 1 kg equal to 1000 gram. So 1 by W kg equal to 1000 by W gram. So I can write small w by molecular mass into 1000 divided by W in gram. The unity of molarity is gram mole per kg. Next is your formality. This is denoted by capital F. Formality means number of formula mass of solute present in 1 liter of solution. Mathematically, I can write formality capital F equal to number of formula mass of solute divided by volume of solution in liter. In most of the cases, formality is equal to molarity. Next, I will discuss about the mole fraction. Having symbol capital X, mole fraction of a component is the ratio of total mole of that component to the total number of mole of solute and solvent in the solution. Mathematically, suppose I want to find the mole fraction of solvent. Suppose it is denoted by x1. Then what will be the formula? Mole fraction of the solvent equal to total mole of solvent. Suppose that is taken as small n1 divided by total mole of solute. Suppose it is taken as small n2 plus total mole of solvent that is taken as small n1. So I can write x1 equal to n1 divided by n2 plus n1. Like this, I can also write mole fraction of solute. Suppose this is taken as x2, then I can write mole fraction of solute x2 equal to n2 by n2 plus n1. Remember an important point, x1 plus x2 equal to 1. Next I will explain about parts per million. It is shortly represented as ppm. Parts per million means number of parts by mass of solute present in 10 to the 6 parts by mass of solution. How many parts by mass of solute present in 10 to the 6 parts by mass of solution? That is called ppm. Mathematically, ppm equal to mass of solute divided by mass of solution into 10 to the 6. This is the formula for the calculation of ppm. Next I will explain interrelation of various concentration term. Remember some important formula. GPL is equal to normality into equivalent mass. Also GPL equal to molarity into molecular mass. Next is your normality by molarity equal to molecular mass by equivalent mass. Next is your normality equal to molarity into acidity. Next is your normality equal to molarity into basicity. Next formula is your molarity equal to percentage strength into density into 10 divided by molecular mass of solute. Next formula is your normality equal to percentage strength into density into 10 divided by equivalent mass of solute. Next formula is your molality small m equal to x2 by x1 into 1000 by m1, where x2 equal to mole fraction of solvent, x1 equal to mole fraction of solute, m1 equal to molecular mass of solvent. There are also another formula that is said to be dilution equation. Concentration 1 into volume 1 equal to concentration 2 into volume 2. I can write N1 V1 equal to N2 V2. This relation is used for neutralization reaction of acid and base. If N1 is the normality of acid and V1 is the volume of acid, then N2 is the normality of base, V2 is the volume of base. This is called normality equation. Like this, I can also write M1 V1 equal to M2 V2. If M1 is the molarity of acid, V1 is the volume of acid, then M2 is the molarity of base, V2 is the volume of base. I can also write another formula M mix into V mix equal to M1 V1 plus M2 V2. Here V mix equal to V1 plus V2. Remember, here M mix not equal to M1 plus M2. This is called molarity equation. It is bound to remember all the formula, otherwise you cannot able to solve the problem. Now I will do some problem related to the concentration of solution. First problem is your 10 ml of H2SO4 are dissolved in 1 liter of water. Find the volume percentage of the solution. Here volume of solute is 10 ml, volume of solvent is your 1 liter. So I can write here volume of solute equal to 10 ml, volume of solvent equal to 1 liter equal to 1000 ml. We know that V by V percentage equal to volume of Here volume of solute is given, but volume of solution is not given. So our first time calculate the volume of solution. Volume of solution equal to volume of solute plus volume of solvent. That means volume of solution equal to 10 plus 1000, that is 1010 ml. Now put the value of volume of solute and volume of solution here. That means I can write V by V percentage equal to 10 by 1010 into 100. By calculation, I can able to write V by V percentage equal to 0.99. Our question is find out the volume percentage of the solution. The volume percentage of the solution is 0.99. Now I will solve the problem number 2. A solution is prepared by dissolving 0.63 gram of H2O2 in 100 ml of water. Find the normality of the solution. We know that normality capital N equal to W by equivalent mass into 1000 V in ml. Here V equal to 100 ml, W equal to 0.63 gram. Here equivalent mass of H2O2 is not given. We know that equivalent mass of H2O2 equal to molecular mass of H2O2 divided by 2. That means I can write 34 divided by 2 equal to 17. Here molecular mass of H2O2 equal to 34. Now put the value of V, W equivalent mass in this equation. Then I can write normality equal to 0.63 divided by 17 into 1000 divided by 100. By solving, I can write normality equal to 0.37 n. Our question is find the normality of the solution. So I can write normality of the solution equal to 0.37 n. Next I will solve the problem number 3. 4 gram of NaOH are dissolved in 200 ml aqueous solution. Find the molarity of the solution. We know that molarity equal to W by molecular mass into 1000 V in ml. Here B equal to 200 ml, W is equal to 4 gram. Molecular mass of sodium hydroxide is 40. Now put the value of V, W, molecular mass in this equation. Then I can write molarity equal to 4 by 40 into 1000 by 200. After solving, I can write molarity M equal to 0.5 m. Our question is find out the molarity of the solution. So I can write molarity of the solution equal to 0.5 m. Now I will solve problem number 4. Calculate the molarity of potassium carbonate solution which is formed by dissolving 2.51 gram of it in 1 liter of solution. Density of the solution is 0.85 gram per ml. Our aim to find out the molarity. We know that molality small m equal to W by molecular mass into 1000 by capital W in gram. This small w indicate the weight of the solute. This capital W indicate the weight of the solvent. Here small w, that is the weight of solute, is 2.51 gram. Molecular mass of potassium carbonate equal to 138. Now our aim to find out the capital W. Here density is given, that means the density of solution is given, that is 0.85 gram per ml. We know that density equal to mass by volume, so we can write mass of solution divided by volume of solution equal to 0.85 gram per ml. Here volume of solution is 1 liter, that means 1000 ml. Now put the volume of solution here. So I can write mass of solution divided by 1000 ml equal to 0.85 gram per ml. That means mass of solution equal to 850 gram, that means 850 gram. Mass of solution equal to mass of solute plus mass of solvent. So I can write mass of solute plus mass of solvent equal to 850 gram. We know that mass of solute equal to 2.51. Now put this value here. I can write 2.51 gram plus mass of solvent equal to 850 gram. That means I can write mass of solvent equal to 850 gram minus 2.51 gram. That means I can write mass of solvent equal to 847.74 gram. This is your said to be capital W.
Now put the value of capital W here.
So I can write molarity M equal to 2.51 divided by 13 into 1000 divided by 847.74. After solving, I can write molarity M equal to 0.0214 small n. Our aim to find out the molarity of potassium carbonate solution. So I can write molarity of potassium carbonate solution equal to 0.0214 m. Next I will solve the problem number 5. Find the strength of the 2 liter solution which contain 50 gram of solute. We know that strength equal to weight of solute in gram divided by volume of solution in liter. Here weight of solute equal to 50 gram, volume of solution equal to 2 liter. Now put these two values here, then I can write strength equal to 50 by 2, that is 25 GPL. Our aim to find out the strength of the solution, so we can write strength of the solution equal to 25 GPL. Now I will solve the problem number 6. If 40 gram of sodium hydroxide is dissolved in 1800 gram of water, then calculate the mole fraction of the solute, that is your mole fraction of NaOH. We know that mole fraction of NaOH equal to total mole of NaOH divided by total mole of NaOH plus total mole of water. Here the weight of water and weight of sodium hydroxide is given. I am to convert the weight into mole. So I can write number of mole of sodium hydroxide equal to 40 by 40. Here weight of sodium hydroxide is equal to 40. Molecular mass of sodium hydroxide is also 40. So I can write number of mole of sodium hydroxide equal to 1. Similarly, I can find the number of mole of water equal to 1800 divided by 18. Here the weight of water equal to 1800 and the molecular mass of water is 18. So I can write number of mole of water equal to 100. Now put these two values here, then I can write mole fraction of NaOH equal to 1 by 1 plus 100, that is 1 by 101 equal to 0.009. Our question, find out the mole fraction of solute NaOH. That means I can write mole fraction of sodium hydroxide equal to 0.009. Next I will solve the problem number 7. What is the concentration of a solution in parts per million if 0.02 gram of NaCl is dissolved in 1000 gram of solution? We know that ppm equal to weight of solute in gram divided by weight of solution in gram into 10 to the power 6. Here weight of solute equal to 0.02 gram, weight of solution equal to 1000 gram. Now put these two values here, then I can write ppm equal to 0.02 divided by 1000 into 10 to the power 6. By solving, I can write ppm equal to 20. Our answer, to find out the concentration of the solution in ppm, so I can write concentration of the solution equal to 20 ppm. Now I will solve the problem number 8. Calculate the formality of sodium thiosulfate solution if 1.24 gram of Na2H2O3.5H2O are dissolved in 100 ml of solution. Like normality, molarity, molality, we can also write a formula for formality. F equal to weight of the solute divided by formula mass into 1000 divided by V in ml. Here V is 100 ml, W equal to 1.24 gram, formula mass of Na2H2O3.5H2O equal to 248. Now put the value of V, W, formula mass in this relation, then I can write formality F equal to 1.24 divided by 248 into 1000 divided by 100. By solving, I can write formality F equal to 0.009 F. Our question find out the formality of the solution. So we can write formality of the sodium thiosulfate solution equal to 0.05 F. Now I will solve the problem number 9. If 200 ml of 2.5 molarity solution of NaCl is diluted to 250 ml, find the molarity of dilute NaCl solution. Here M1 equal to 2.5 m, V1 equal to 200 ml, M2 is unknown, V2 is 250 ml. We know that M1 V1 equal to M2 V2. Now put the value of M1 V1 V2 here. Then I can write 2.5 into 200 equal to M2 into 250. Imply that I can write M2 equal to 2.5 into 200 divided by 250. After solving, I can write M2 equal to 2m. Our aim to find out the molarity of dilute NaCl solution. So we can write molarity of dilute NaCl solution equal to 2m. Now I will solve the problem number 10. Calculate the normality of the dilute HCl solution. If 100 ml of water is added, 400 ml of 1.6 normality solution of HCl. Here N1 equal to 1.6n, V1 equal to 400 ml. Remember an important point. Here 100 ml water is added with this solution. So the new volume is your V2 equal to 400 ml plus 100 ml. That means 500 ml. Our aim to find out the N2. We know that N1 V1 equal to N2 V2. Put the value of N1 V1 V2 here. Then I can write 1.6 into 400 equal to N2 into 500. So I can write N2 equal to 1.6 into 400 divided by 500. After solving, I can write N2 equal to 1.28 n. Our aim to find out the normality of the dilute HCl solution. So I can write normality of the dilute HCl solution equal to 1.28 n. Now I will solve the problem number 11. Calculate the volume of 1m solution of HCl and 0.25 m solution of HCl which are mixed with each other to form 1 liter of 0.5 m HCl solution. Here M1 equal to 1m,
M2 equal to 0.25 m, M mix is equal to 0.5 m.
V mix equal to 1 liter. Let the volume of 1m solution of HCl equal to x liter. Therefore I can write volume of 0.25 m solution of HCl equal to 1 minus x liter, because the sum of these two volume is equal to 1 liter. This is taken as V1, this is taken as V2. We know that V mix equal to 1 liter. Again, we know that M mix into V mix equal to M1 V1 plus M2 V2. Now put all the value in this relation. Then I can write 1 1 into 0.5 equal to 1 into x plus 0.25 into 1 minus x. Imply that I can write 0.5 equal to x plus 0.25 minus 0.25x. Imply that I can write 0.5 minus 0.25 equal to x minus 0.25x. Imply that 0.75x equal to 0.25. Imply that x equal to 0.25 divided by 0.75 equal to 0.33. Imply that 1 minus x equal to 1 minus 0.33 equal to 0.67. Here x is the volume of 1m solution of HCl. 1 minus x is the volume of 0.25 m solution of HCl. Our question to find out the volume of 1m solution of HCl and volume of 0.25 m solution of HCl. So I can write volume of 1m solution of HCl equal to 0.33 liter and the volume of 0.25 m solution of HCl equal to 0.67 liter. These are the problem related to the concentration of the solution.